Hey, welcome to Pomodoro Joe for Saturday, October 7th, 2023. Today we're doing LeetCode problem 1420. Build array where you can find the maximum exactly k comparisons. What? Anyway, it's a hard problem. I don't have a ton of time today, so we're going to go through this fast. You are given three integers, n, m, and k. Consider the following algorithm to find the maximum element of an array of positive integers, and then they give us some code. So it looks like we just go through every integer. Let's see, our index from 0 to n. And if we have a new maximum value, if our current maximum is less than that value at that index, then we replace it. And we have one more cost. So we add one to our search cost. All right, and our max starts at -1. Okay, you should build the array R, which has the following properties. Okay, the array has exactly n integers. Let's see. 1 is less than or equal to the array at index I, which is less than or equal to m, where 0 is less than or equal to I less than n. All right, so what this is saying is that for every element in our array, it has to be between 1 and m, inclusive. Okay, after applying the mentioned algorithm to the array, the value, search cost, is equal to k. Okay, so we have to go through our array here. And every time we have a new maximum element, our search cost goes up by 1. So we have to do that exactly k times. So we have to find k new maximum elements. All right, return the number of ways to build the array under the mentioned conditions. As the answer may grow large, the answer must be computed modulo 10 to the 9th plus 7. All right, so we're given three numbers, n, m, and k. N is the number of elements in our array. M is the maximum value of an element in the array, and k is the number of times we want to find a maximum value. Okay, not necessarily m, just a new maximum value as we go through the array from left to right. In our example, we have 2, 3, and 1. There are 6 possible ways to do this. We have 1, 1. Interesting. So we can reuse the same number. So 1 and 1 means there's only one swap, and that happens, I guess, at the very beginning because we start with a maximum value of -1. So 1 and 1, we have one new maximum value from -1 to 1 here. And then 2 and 1, same thing, we only have one swap from -1 to 2. 1, 1, okay, so this makes sense. Whatever our first element is, that is our one swap, our 1k. And then anything else has to be below that new element. So it can be 2 to 1 or 2 to 2, but you can't go from 2 to 3. All right? And m being our maximum value, the max value we could have is 3. So this is our answer, 6. All right, example 2. N is 5, m is 2, k is 3. There are 0 ways to do this because with m being 2, you can only have 2 numbers. K you have to swap 3 times, and you can't swap 3 times with only 2 numbers. All right. And our last one here. We have 9 elements, but m is 1, so we can only have the value 1, and k is 1. So we swap 1 from -1 to 1 at the very beginning, and then everything else has to be 1, so there's only one way to do this. All right. Okay, let's put 25 minutes on the Pomodoro timer, and we will get started. So I don't really know how to do this, but I think the best way to approach the problem is through a recursive algorithm, because I do know I have to build up an array. It has to be n elements long, so I can choose my first element and then recurse on a new array of n-1 elements. So I know I can reduce the problem a little bit each time. So let's start with just a recursive function. We'll do num of arrays recurse. And let's see. For now, I'm just going to pass in the same variables that we start with. So it'll be a remaining n, so rn, remaining m, and remaining k, because I will be reducing these values. I'll reduce the remaining n and the remaining k, and maybe the remaining m. We'll find out. All right, so every step along the way, I want to be reducing at least one of these values, most likely this remaining n. So if I choose one value, like I choose the very first element of my array, then I have remaining n-1 new elements or elements left in my array. So what's my base case then? Well, I'm out of elements. If I get to this remaining n is equal to 0, we're out of elements to choose from. We're at the end of our array. So my base case will be if remaining n is equal to 0, then what do we return? So we could return Well, I guess it depends on what my remaining k is. We need to have a remaining k equal to 0. That means we've actually used all of the k swaps, or switches of maximum value. So we'll return 1 if k, remaining k, is equal to 0. Otherwise, if we reach 0 elements, we don't have any elements left to put in our array, but our k isn't 0, that means we still have some swaps we need to do. Well, then we have 0. This doesn't count. We can't use this branch of our recursion. All right, so that handles the base case. What other base cases do we have? Well, we could have remaining m reaching 0, but right now we're not reducing m at all. We could also have remaining k reduced to 0, but I think I'm only going to be reducing my k if I choose an element. So that's already kind of wrapped up in this remaining n is equal to 0. So I think we've got it covered actually. At this point, this is our one base case. All right, so now we can look at our recursive calls. What are the options here? There's basically two options. Every time we're going through, we're going to choose one number to put into our array. So we'll definitely be reducing our number count, our remaining n, every time through our recursive call, but we don't necessarily reduce the other values. We may reduce our k if we've done a swap. Like if we choose a number for this value and it happens to be greater than our maximum, then we'll do a swap and then I'll reduce my k. All right, so there are basically two recursive options. One, we choose a number that is less than our current maximum value, which means that we reduce our number count, but we don't reduce our k because we didn't do any swap. Or we choose a number that's greater than our current maximum value, in which case we reduce our number count and we reduce the number of k we have left. So let's do this. Option 1. We'll select a value that is less than our maximum. Let me do it this way. Instead of saying choose a value less than maximum, option 1, we'll select a value that doesn't cause a swap. Okay, so option 1, we're going to select some number to put into our array that's not going to cause our maximum value to flip or to change, which means our k doesn't get reduced. Okay, so what number do we choose? Well, we can choose more than one number. There's lots of different options. We can choose 1, 2, 3, up to some maximum number that we've chosen. So let's see, for every, I can't use n, I'll call it x. For every x in range, now our numbers have to go between 1 and m. So we'll start with for range 1 to m plus 1, because this is inclusive of m. I can do a check here. If this number is greater than our current maximum, we don't actually have our current maximum. So this is something we'll have to track. We'll have to track our current maximum. So let's actually just do this. From 1 to our current maximum. Again, plus 1. So these are going to be all the numbers between 1 and our current maximum, including the current maximum itself. Now, any of these numbers we can choose, perfectly valid number, and it won't cause our maximum here to switch, so our k will not reduce. All right, so that means this option 1 will equal our recursive call with remaining n minus 1, because we've just chosen one new number, so our remaining n gets reduced by 1. Now our m doesn't change because we haven't changed our maximum value, and our remaining k doesn't change either because we didn't actually make a swap, so the remaining k stays the same. Cool, so that's option 1. Now what about option 2? So option 2, now we'll choose some number that's greater than our current maximum. That's going to cause our maximum value to flip, so we'll do this switch, and our remaining k, we use 1 of our k to do that switch, so the remaining k will reduce by 1. See why. All right, again, we'll have some for loop. How many numbers can we choose from here? Well, this will be from our range of our current maximum value plus 1, because we have to choose some number greater than our current max, and we can go all the way up to m, and we can include m, so we can go to m plus 1. So this gives us all the values that will cause a flip in our k, or a flip in our max value, which causes a reduction of our k. All right, so option 2, that's going to be this num of array recurse, rn minus 1, because we've chosen a number. Our m stays the same, and our remaining k gets reduced by 1. and our remaining k gets reduced by 1 because we're causing this max value to change. So these are our two options. And in fact, both of these options will add to our result. Let's keep track of our result up here. So we'll have some result to begin with. That's going to equal 0. Then when we go through, every time we have this option, our result will increase by this amount. And same thing with option 2. So these are all the recursive calls and all our options. We just add to the result. Now at the end, we do need to return our result, and we have to do this modulo. So we'll do result, and we'll do mod, and I'll call it mod val. So out here, let's create our mod val. And that's just going to be 10 to the 9th plus 7, so 10 to the 9th plus 7. All right. Now, two things left to do. One, this current max. So this current max, we actually don't have. I just sort of made this up. I know I need a current max. So where do we get this current max from? Well, let's pass it in. So let's do that out here. So pass in our current max. And we'll set it to some initial value, which in this case will be -1. So our current maximum starts at -1. All right. So we'll go through, do our calculations, and that does mean that in our recursive calls, we have to pass along our current max. Now in this case, our maximum value didn't change, so we just pass it through. Now in this case, option number 2, our maximum value did change. So now we have to pass through x. This is our new maximum value. All right, and a couple other things here, some bookkeeping. This m, we're not using, we're using it, but we're not changing it. So we don't actually need to pass this through. We can just grab it from the environment here. So let's get rid of this. We don't need to pass our m through. Cool. And the last thing I think we need to do is we have to kick this whole thing off. So out here, we will return the recursive call, and we will start with n values. We'll start with m, but we don't have to pass that through. We'll start with k. And then our current maximum, we're just going to set initially to -1. Awesome. Now, one last thing before we run this. I already know this is probably going to be slow, so I'm going to use the cache decorator to help speed this up. Great. Let's see if this works. I'm missing something. What did I do wrong? Max value +1, m +1 for x in. There we go. Let's see, this one's not quite working out. We're saying it's 7, the expected 0. So this looks like one of those base cases that we weren't covering. Like our m is 2, but our k is 3. So let's just have some basic checking out here. If k is less than m, let's see, is it less than or less than? No, it's greater than. If m is less than k, then we have to return 0. There are 0 ways to do this. What if they're equal? If m is 2, but k is 2, yes, that's okay, because we can do the initial swap when we go from -1 to the first value of m, and then we can do another swap on the second value of m. Cool. Try that. Okay, so that works. Let's run this and see how we do. All right, and we got a wrong answer. We beat 9 out of 28, so we're close, but we're not quite there. Looks like we are overshooting. All right, let's use this test case and see what's going on. All right, so we return 1 if k is equal to 0, else 0. Okay, I think that's fair. Going through option 1, we're reducing our remaining n, reducing our k. All right, I think what's going on here is this initial value, my current max of -1. So initially with my current maximum of -1, that means that this will be 0, 1 to 0. So that does mean that we skip this, we're not running this. Now I already know that my values have to be between 1 and my max of m. So I can actually set this to 0 to achieve the same goal, because it's still less than my real value, which would have to be at least 1. and that way that this will still run. So let's try that. Okay, and that fixes the problem. Let's see if we can pass all the tests. And we pass. And let's see, how do we do? We don't do great. We only beat 28% for runtime and 18% for memory, so not great. We could try our own caching here, like do our own dynamic programming. Another thing we could do is once we run out of K, like we might still have a lot of array left, even though we have no more swaps we can do. At that point, we have to choose our maximum value for our current value, for our current selected element. And then we can just find the permutations of all the remaining elements. So just by doing a permutation or a factorial, we could save a ton of actual like recursive calls just by doing the math. So that's something to think about. Give it a shot. All right, that's all I have time for today. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.